So first, once again, got to review for your quiz tomorrow. A little review in standard form. How do you get it to standard form? Okay. Remember, standard form is this: ax squared plus bx plus c, right? Where a, b, and c are integers. So how would you get this to be x squared and everything? Yeah, distribute. So we have x times x, x times 3, 2x times 2 times x is 2x, and 2 times 3. So you just distribute 4 times. And of course you can simplify the middle since they both are just x's. We have x squared plus 5x plus 6. So that means a is equal to 1, b is equal to 5, and c is equal to, a is 1, b is equal to 5, c is equal to 6. So that's standard form. Again, you cannot have fractions. Question? Got it? Okay. Yeah, some of you might know this as foiling. We'll play the first, the outers, the inside, and the last numbers. On Friday, made a big deal out of this with all our x's and stuff while we're trying to find our roots and all our graphs. That was like number 3 of several steps. What was the first one you want to check for before you do the x? Yeah, GCF was the first thing. So if it was like 2x squared plus 16x minus 64, the first thing you do is take out a 2. And the second was, yeah, so square roots. So the other problem was if we had like 36x squared equals 25, square root both sides, it can get you to solve it maybe a little faster than factoring. All right. Okay. All right. So let's look at, we already went over that. We're going to be looking at how to simplify radicals, review of that, and to approximate, which is using the approximate sign. So the approximate sign is like a wavy equal sign. We use that when we want to use something like a rounded decimal. So if we need to graph like square root of 3, like how would you actually graph that root? Where would that be? It's about approximately 1.7. So that's what we use anytime we have irrational answers, stuff with square roots. We have to make it a decimal, but we say it's approximately equal to. It's not exactly equal to, like an equal sign, but approximately. It's rounded, so we use an approximate sign. So some of your homeworks will have questions will have answers with approximate values, and it says in the directions when to do that. And we'll practice on your calculator. All right. So let's go ahead, take a look at that, see what comes to mind. All right. And go ahead and put an answer in, and we'll see where we're at right now. So 100% of you got this. Now, go ahead in your calculator, see what the root 28 actually equals as a decimal. Practice, let's do a little practice there. Root 28. And use an approximate sign. What do you get? Let's go to the nearest hundredth. 5.3. 3 what? 5.31. All right. Now do root 7 times 2. What is that approximately equal to? Root 7 times 2 or 2 root 7?
3.1-ish. Oh, 2 times 7.
And you get same thing. Same thing. Why?
Because they are the same.
Because they're equal to each other. Yeah. So equate this to 4 divided by 8 equals 0.5. And so does 1 divided by 2. That equals 0.5 as well. It's similar to reducing a fraction or reducing a radical. They're equal to each other. So it's one of those things like if you ever have 4/8 as an answer, you always reduce it to 1/2. Anytime you have a radical that can be reduced, you always reduce it no matter what. You don't wait for directions or wait, do we have to reduce it? You know, don't ask that question, just yes. It's always yes. It always, the answer to that question has always been yes. Okay? So make sure you always reduce it, but know that they're equal to each other. They are the same. They are the same. So let's try another. Now some of you have calculators that you just plug in square root of 216 and it tells you what the answer is. Others, if you don't have a calculator like that, you're going to have to find out what is the largest perfect square that goes into 216. So 4, 9, 16, 25, 36, 49. You have to find what the largest perfect square that goes into 216. And it helps a little that you have multiple choice because you can work backwards a little bit. So we end up with root what times root what? What do we get?
Oh.
It's not. Alright. So we end up with root 36 times 6, 6 root 6. Now, approximately, what does that equal to?
About 14.
So now get the decimal. Approximately, what does that equal to? 14? 6, 9, or what's that? What's after 9?
Another 6, 9.
So that would actually go to 7. Oh, round up, round properly there, right? And use the approximate sign. Because this is a rounded answer. Anytime you see something rounded, use the approximate sign. Good. Another? Try this one 100% on your own. See if you can do it by yourself. We'll drop it down to like 30 seconds total. Good, good, good. A few more seconds. Seven and 19. Good. 19. Something in. So yeah, it looks like we're mostly on the ball. Let me look at the names who.
You got a round?
D.
That was an fix for the day.
So on number 5, root 72. Very important. What is the largest square root that goes into 72? Largest is 36. So I'm just going to point out a few places where we commonly see errors. If you see 72, it's very tempting just to say, well, that's 9 and 8. But 9 is not the biggest square root that goes into 72. So making sure you use 6, sorry. 6 root. Use the largest square root. Right? Yes. Yes. As long as you get this answer, it's fine. Number 9. What if there's a coefficient out front, a rational part? So this is the rational part. It doesn't have a square root. This is the irrational part. So just kind of leave it alone. Simplify the irrational part. So what's the largest square root that largest perfect square that goes into 54? You should come up with 9. Square root of 9 is 3.
3.
And then everything else, let's bring it down. And at the very end, we have 2 parts that are rational, 1 part that's irrational, and 2 parts that are rational, which multiply together. So, I gave you an example of a commonly missed problem because you don't use the largest square root. I gave you an example of, well, what if there's a rational part already in front of the irrational part? You just basically leave it out there until the very end. All of this stuff right here is the same. Question?
How do you enter this into a calculator to check the right word?
All right, we'll go over that in a moment. Let's just use exact. And then lastly, what does this reduce to? Root 30. Any perfect square goes into 30? No. So the answer is -3 times root 30. So just like a fraction, if I gave you like 17 over 18, yeah, you try to reduce it, but not every fraction reduces, not every radical reduces. But we always try no matter what. And without being told and without being on directions, you always reduce fractions and radicals. Alright, so that's the front. Go ahead and work on that a little bit longer, finish it all up. And then we'll start with the back. Really going to need to use a calculator. We'll get to the back. So remember, this is the part of the quadratic formula. After you plug everything in, we'll get something that looks like this. Either if it's a perfect square, we'll get a nice number here, or we might get the square root of something, either real or rational or not rational. So square root of 16 is rational, so it'll be 4. Here it's irrational. So what we want to do is go ahead and get our 2 answers. What we're doing right now, when we have a problem like this, watch up here. Remember, this is coming from quadratic formula, which you will be doing tomorrow. So after we plug in a, b, and c, so x equals -b plus or minus the square root of b squared minus 4ac all over 2a, you'll plug in numbers and it'll turn out to something like this. After you reduce the discriminant, which is the part inside the square root, you'll get something like this. So the question is, how do you reduce this all the way? And how do you approximate the answers? So here's an example of reducing all the way, like we just did on the front. We can take root 20, and using the steps we just went over, root 20 reduces to 2 root 5. Using the method, root 4 times root 5, root 4 equals 2. I'll trust that you know how to go from root 20 to root 5 based upon what we just went over, or just using your calculator and checking it. Now, how do you reduce this part? How do you reduce this? Now, here's the thing. If you can, you have to divide this number, or a factor of this number, by both. So does 2 go into 10? And does 2 go into 2? Yeah, so we can use distributive property and say, yeah, 2 goes into 10 5 times, and then also 2 goes into 2 1 time. But like usual, we don't write the 1. So our answer fully reduced is going to be 5 plus or minus root 5. So that's the exact answer with an equals. Now the next part is, well, what does this approximately equal? What are the 2 decimals? Those are 2 answers. So you have to type in 5 plus root 5 and 5 minus root 5. So in your calculator, go ahead and do that right now. All right, our 2 decimals are what? 9 point what?
Oh, you see it? I thought you had the answer.
7.2, 2.8.
What are the 2 decimals you guys got?
7.2, 2.8.
7.25 and
2.8 something else.
2 point. 2 point what? 2.76. So you put these in the braces because x equals both. So if you had to graph all this, you kind of have a better idea. You know, this number right here, that's the vertex. So is that down the middle? It's at 5. And it means there's going to be 1 root 5 to the right, plus root 5, and 1 root 5 to the left. So you end up with roots at 2.76 and 7.25. And I know this is going to be, well, I don't have the original equation, so I don't know if this is opening up, opening down. But that's what this is. It's kind of getting those exact or approximate roots. So yeah, this number in front is always going to be that axis of symmetry. We know that's the middle of the graph. So with all the other information from the equation, like does it open up, open down, what's the y-intercept, we could plug in 5 into the original equation to find out where the vertex is. Maybe it's up here. And we know approximately, you know, what the graph looks like. And we know what the roots are. Remember, we can't get these from factoring. That's why we're doing all this. That's why we're going to be using quadratic formula. All right. So have to reduce this all the way. This will be considered the exact answer, and then approximate the answers right here. All right. So let's go to here. I want to show you this one. Just watch on this one. 6 root 48 reduces to root 16. Remember, you don't have to actually show this to me on your work. I'm just showing you here. But if you can go straight to this, which is 4 root 3, okay. Does this reduce any more?
Did you divide the 2 or the 3 into the 6?
Well, 3 goes into 6,
Into
but
the
3
4?
does not go into 4.
Oh, no, that's my fault. I thought it was 2.
So this is one of those things like if you get a fraction like, I don't know, it's not 18 over 13, and you look at this and say, well, does anything go into both of them? No, can't reduce it. Does 3 go into both of these? No, you can't reduce it. So just like a fraction, it has to go into both. So part of reducing is knowing when it does not reduce. You're not going to try to force everything to be reduced. We're definitely not going to cancel out anything in the radical with a regular number, because if you put this in the calculator, it's like 1.7. You can't cancel out 1.7 with a regular 3. It doesn't equal 1. So we can't type anything inside the radical. So knowing when to reduce and when to just leave it alone is important. So back to your work. On these, you just get 2 answers, and they're exact because there's no radicals involved. We get 10 plus 8 18. 18 divided by 2 is 9. And we get 10 minus 8, which is 2. 2 divided by 2 is 1. So there's our answers with an equal sign, 9 and 1, in braces. On number 4, yeah, we can reduce that. That's going to be, the square root of 16 is 4. So 5 plus 4 is 9. 9 over 6 is, what does that reduce to? 9 over 6 reduces to
3 over 2.
3 over 2. So always leaving fractions if you're able to. Leave as a fraction. Now, 5 minus 4 is 1. 1 over 6. This is 1 over 6 doesn't reduce. There's our two answers. And brace. So you get two answers exact for all those. When you get to number 7, you see, well, this is not a rational number, so we can't get a rational answer. Questions, guys?
What about the one with the square root of 0?
Oh, the square root of 0 equals 0. So you'll do 1 plus 0, 1 minus 0, and see what you get. Square root of 0 equals 0. Here, this is where no longer can we use an equal sign. You can't say the square root of 3 equals anything. It's approximately equal to like 1.7. So this is where you have to use your calculator and say, well, this is going to be approximately equal to what? And in your calculator, you have to do 1 plus root 3 divided by negative 3, and 1 minus root 3 divided by negative 3. And you have to do this very carefully. I know you want to think just plug it in and see what comes out, it must be right, but there are some ways of plugging things in that won't be what you think. So let's practice this right now and make sure the right thing shows up. Okay, so the two answers came out to approximately negative 9.1, negative 0.91, sorry, and 0.24. Alright, so we're going to put those in braces. And remember, they're approximately. They're all decimals. Approximately. Alright, let's go to number 10. So, does this reduce? Does the radical here reduce at all?
Yeah.
Root 32, does that reduce?
Yes.
Yes. So when it's possible, just like a fraction, you have to check to see if it reduces. You can't say, 32, no, I don't think so. You have to really check. Does a perfect square going to 32? Yes, and then reduce it. You get 4 root 2. Right. Lastly, can 8 or a factor of 8 go into both of these numbers? Yeah, these all have a factor of 4. 20 goes into 4 goes into 20, 4 goes into 4, and 4 goes into 8. So you have to reduce it. Divide everything by 4, except the irrational part. So negative 20 divided by 4, negative 5. 4 divided by 4, just 1. So we'll just have 1 root 2. 8 divided by 4 is 2. So I just divided every rational part by 4. Again, this is distributive property. I have to divide everything on top by the number on the bottom. And then and only then can you say, well, this is approximately equal to the 2 decimals. And you plug in your calculator and you find out, what is negative 5 plus root 2 divided by 2, and the second one as well. So I have some on here that give you nice rational answers or fractions, some that give you irrational answers, some like 10, 11, and 12 where you have to reduce the radical to get the exact answer, and then get the irrational. So there's different levels of work here. Again, if you have one of the calculators that goes from root 32 to 4 root 2, it's very handy. Very handy. It's less than a $20 investment, and it's something that's very nice on a test. Okay. Very nice. Lastly, before the bell rings, still got some time to work, but I want to show it to you. Just recall with the quadratic formula, you have to plug in A, B, and C. I just want to make sure that you know how to solve and get those. So when it's equal to 0, A is the term in front of the x squared, B is the term in front of the x, C is the term that's by itself, the constant term, no variable.
Oh, that's why it's C.
So like right here, you notice how this is not equal to 0. So you have to subtract 2 on both sides. And you have to realize, well, this is negative 2x. It goes between the 4x squared and the 2. Always in descending order. So we have A equals 4, B equals negative 2, C equals positive 2. All right. See you tomorrow.